Ignition sequence start.
Good morning, and welcome into the International Space Station Flight Control Room at NASA's Johnson Space Center. This is where there's always a team of specialists on duty to keep a close eye on the operation of station systems and assist the human crew members with their daily tasks on orbit. Commander Anton Shkaplerov and his American, Russian, and German crewmates are finishing up a week when they've spent a lot of time working on science experiments. They're also taking care of another ship full of supplies delivered to their door.
Houston Station on Space to Ground.
Welcome to Space to Ground. I'm Sandra Jones. This week, a cargo ship packed with food, fuel, and supplies arrived to the International Space Station, and science research on flames in space continues.
We have engine ignition.
On February 19th, the uncrewed Northrop Grumman CRS-17 Cygnus cargo craft blasted off from Launch Pad 0A at the Wallops Flight Facility in Virginia, carrying 8,300 pounds of science investigations, fresh foods, and cargo. The Cygnus, named the SS Piers Sellers after the late NASA astronaut and climate scientist, arrived to the space station 2 days later. NASA astronaut Rajachari used the Canadarm2 to capture Cygnus, and it was then installed to the Unity module of the space station.
Congratulations to the MCC-H and Dulles team and to Northrop Grumman, and welcome aboard again to Piers Sellers. He worked at Goddard and climate science, and it's a daily reminder to us with the experiments on board to help with the climate of the Earth in his name and legacy, and we're happy to be a part of that.
As one important flame study investigation reaches its end, a new one is about to begin. Since 2017, the Advanced Combustion via Microgravity Experiments, or ACME, conducted 6 studies in which 7 gaseous fuels were burned, and over 1,500 flames were ignited and studied. The goal of ACME was to study flammability, improve engine efficiency, and reduce pollutant emission in combustion, as well as to better understand how to prevent fires in spacecraft. Now, the Solid Fuel Ignition and Extinction Facility, or SOFI, builds on the work of ACME with a new series of investigations studying flames in new ways, such as material ignition and suppression. Launched aboard NG-17, SOFI will help NASA select materials and designs for spacesuits, cabins, and habitats. The experiment will also help NASA identify the best ways to put out fires or smolder materials in space. Skin aging may be inevitable, but the unique microgravity environment of space may accelerate the rate of skin aging. A newly arrived study seeks to investigate the underlying molecular mechanisms that drive skin deterioration. The Colgate Skin Aging Investigation arrived on NG-17 and consists of a model that uses human skin cells on a porous membrane to mimic the 3D organization of skin tissue. This study evaluates the cellular and molecular alterations associated with growth in microgravity compared to the normal aging process on Earth. The results from this investigation could help create and validate engineered tissue to protect aging skin heal from wounds and combat infection. And that's Space to Ground for this week. Thanks so much for watching. We'll see you next week.
The International Space Station's laboratory modules support experiments in a number of scientific disciplines. For example, the Flame Design Investigation is looking into the quantity of soot produced under different burning conditions, and that could generate data that leads to the creation of new burners that are more efficient and less polluting. Being the hands in hands-on science research in space is one part of the job description for an International Space Station crew member. The astronauts and cosmonauts share the experience of being in space with us Earthlings, and they talk to students about key scientific concepts, as astronaut Mark Van de Heij demonstrates in this demonstrations video.
Welcome to the International Space Station. I'm NASA astronaut Mark Van de Heij. Today, we're going to talk about Newton's third law. How do you think it will hold up in microgravity?
For every action, there is an equal and opposite reaction. This means that in every interaction between two objects, there are a pair of opposite forces acting on each object at the same time, a force pair. You can see that there are many examples on Earth. In space, thrusters expel one way and the vehicle is steered in the opposite way.
Hello again. More basketball stunts that I can't do on the ground, at least not while getting this much hang time. All right, back to serious business. Got a basketball right here. It's going to be object 1. I'm the second object. If object 2, myself, applies a force to object 1, then that same force will be applied, according to Newton's third law, by object 1 onto object 2. However, there's a big disparity in the mass. Object 1 is a very light mass object. Object 2, myself, is a larger mass object. So I'm going to try to make myself about the same shape as this ball. See how that works for us. And I'm going to apply that force. You saw that force applied to the ball made it accelerate quite a bit. It really didn't accelerate me much at all. Newton's third law again, but this time we're going to use two similarly massed objects. Joe and I have about the same mass, so Joe, get into a ball. I'll do the same. I'm going to face you this way so that I don't throw you into something you can't see. Now I'm going to get into a ball behind Joe, and I'm going to apply a force to him. Notice that when I applied a force to Joe, it accelerated Joe away from me, but I got accelerated away from him as well, because the force applied to Joe ended up being the same force that was applied to me. Now you've seen Newton's third law in space. Now test it out on Earth. See you next time.
Along with messages about scientific concepts, there are other ways for International Space Station crew members to connect with Earth. Like the time one station crew member saw a natural disaster unfolding on Earth right below him and found a way to help.
The first pictures now coming in from Puerto Rico after taking a direct hit. Hurricane Maria slamming into the island. One official saying the island is destroyed.
Hours with winds and rain, and didn't stop.
Power lines are down. Streets are impassable. Many roads are flooded.
High winds uprooting trees, overturning cars, and turning buildings into piles of twisted metal.
It is something that will change Puerto Rico forever.
We had no water, no food, no gasoline, no communication at all.
Not knowing where my next meal will come from, it hasn't been easy.
After Hurricane Maria, everything was gray, all the plants were dead. Hurricane Maria took the color away from us.
I am sure that these children will not be the same. They will not be the same. They are still struggling and trying to recover from this.
My name is Joe Acaba. I'm a NASA astronaut of Puerto Rican descent. I was about a week into my mission on the International Space Station. Hurricane Maria was forming up, and from there, if you looked out the window, you know, Maria took up a big chunk of what we could see. It was going to cover the entire island. After the hurricane, their power grid was pretty much taken out. You know, you just couldn't see the island anymore. The hurricane, I think, had a huge impact on, you know, the island as a whole, but especially the kids.
Joe Acaba was our hero, and we need something positive. The students need something positive.
We wanted to pull through, forget all that happened, and lift up our spirits and lift off the island.
So I knew I couldn't do much from up on the International Space Station, but I did want to connect with the students to show them that there is hope and that there are people out there that care about them.
NASA has the STEM station, which allows the students and teachers to talk to the astronaut in the space station.
It's making that connection so that maybe, you know, they become more interested and we can inspire them more to study the STEM fields.
So we were able to establish and coordinate with NASA one of these video conferences. Thousands of students from different parts of the island watching the video conference with the space station, talking to Joe.
This is Joe aboard the International Space Station. I have you loud and clear.
How do you compare?
What is the most impressive?
How did Puerto Rico look?
Are astronauts allowed to visit?
What is the minimum number of?
It was awesome because, you know, as soon as it came up, you could hear people clapping, people were excited. So even though I couldn't see them, you know, I could feel them, and that was pretty neat.
It was amazing. He called from the International Space Station to see how Puerto Rico was doing, and that means a lot for us, a lot.
In May of 2018, I was able to go back to the island, my first time since the hurricane. It was a great opportunity to get out and kind of come full circle with those students, to go and see them in person and, you know, kind of reiterate how important they are, and just to give them a little bit more hope because there's still a long way to go on the island.
He's a hero for us. Kids love him, and everybody loves him here. Joe Acaba is the role model that we need at this time.
I want to be like him. I want to go far, and I want to be an example for little kids when I'm older.
Not only is the International Space Station a great tool for scientific research and exploration, but for students from Puerto Rico in particular, I think that having that video conference with them, it did provide some hope. It did provide some inspiration. And so it's just one of the benefits that we get from the International Space Station.
A major goal of the International Space Station program is to develop the tools and techniques we will need to be successful in the next stage of human exploration of space, starting with the Artemis program and the missions to the moon that are coming soon. The folks at NASA's Exploration and In-Space Services Projects Division at the Goddard Space Flight Center have worked up a number of these new tools that have been tested on this space station to help draw up the blueprint for our sustained human presence in space.
The International Space Station has been providing us with groundbreaking science and discoveries for over 2 decades. When you think of humans as a spacefaring species, you may think of it as something limited to the future or science fiction. But in fact, for more than 20 years, humans have maintained a continuous presence in space via the space station. During that time, we have reaped the benefits of the research and science conducted on board. We have also managed to learn and develop engineering capabilities on the prime real estate outside.
Some of the really unique things we've been able to do on the ISS include things around robotics and autonomy, and especially with a new national capability, an initiative we have going on around on-orbit satellite servicing, assembly, and manufacturing. I would tell you that the ISS was really at the forefront of us starting this activity.
There is still so much left to learn and so much technology left to be tested in this incredibly unique place.
Really, the ISS as an orbiting lab provides the agency with the opportunity to test things in a microgravity environment. The main difference between terrestrial Earth testing and ISS is exactly that microgravity factor.
Using Station to practice capabilities and see how technologies will look and work in space is comparable to having a dress rehearsal before a big play. It provides us with the opportunity to learn, adapt, and tweak things as needed to drive down mission risk and increase the chance of success. This is especially important when you consider that many of these technologies and capabilities are things that have never been done before. Things like robotically refueling satellites in space that weren't designed to be refueled. NASA has big plans for sustainable exploration at the Moon, Mars, and beyond. First on the docket is Artemis, for which NASA plans to send the first woman and the next man to the Moon. In addition to testing technologies, Station also provides NASA with the blueprint for long-term human habitats in space. From learning about how human bodies adapt to a space environment in the long term, to discovering how to grow food and more, the orbiting lab provides invaluable lessons. As part of the Artemis program, Gateway will be an outpost orbiting the Moon, similar to the way Station orbits the Earth. Like Station, it will act as a destination for astronaut expeditions and science investigations. Unlike Station, it could serve as a port for deep space transportation, such as landers en route to the lunar surface or spacecraft embarking to destinations beyond the Moon. Gateway is a critical component of NASA's Artemis program and is possible thanks to strides made with Station.
So many technologies are required for us to sustain presence both lunar and then eventually when we go onto Mars. But with the Artemis program especially, and the lunar surface initiatives we're looking at now involve advanced power capabilities, advanced propulsion, advanced communications, trying to go to optical communications from radio frequency, entry, descent, and landing of large scale mass. And again, the robotics and autonomy I'll keep going back to, those as well. But many different technological challenges, exist and are needed for us to be able to sustain those. What we're doing now will determine the future of what the agency's capabilities are.
The International Space Station offers endless possibilities in the future to continue to advance our identity as a spacefaring species.
The International Space Station was designed to be a place where people can learn what they need to know to be able to explore beyond low Earth orbit, as we'll be doing in the next few years as we build a sustainable community on the Moon through the Artemis program. Join narrator Drew Barrymore to learn why returning to the Moon is the natural next step in human exploration, and how the lessons learned from Artemis will pave the way to Mars and beyond.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the Moon, and this is why.
The Moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the Moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the Moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the Moon is a shared effort.
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
We'll use the lessons from more than 50 years of peaceful exploration to send a new generation to the lunar surface to stay.
We will anchor our efforts on the lunar South Pole to establish the Artemis Base Camp,
positioning us for long-term science and exploration of the lunar surface.
We will prove what it takes to assemble a complex ship in deep space.
We will perfect descending down to and returning from a distant surface.
We will learn how humans can survive and thrive in a partial gravity environment.
With improved spacesuit designs, mobile habitats, and with reconnaissance robots pre-positioning and relocating supplies.
We will learn how to utilize the resources we find on these other worlds, starting with finding water ice and purifying it to drinkable water.
And refining that into hydrogen for fuel and oxygen to breathe.
We will establish fission power plants on the surface of the moon capable of supporting a growing community of efforts.
And we will expand the logistics supply chain to enable commercial and international partners
to resupply and refuel deep space outposts.
None of this is simple or easy, but nothing in our history ever has been.
The Eagle has landed. You got a bunch of guys about to turn blue. We're breathing again. Thanks a lot.
This kind of continuous lunar presence is a natural extension of all that we've learned in low Earth orbit. And what we will accomplish there will ensure the monumental missions to Mars are within reach. As we ready the launch of the first Artemis mission, and as commercial companies ready their lunar landers for the first private payload deliveries, we have already begun to take the next step.
There is one thing that explorers all throughout time have had in common. They're all at the mercy of the weather. And while things like rain, wind, and lightning all factor in, you can't forget about radiation. The astronauts and the systems of their future space vehicles will have to be protected from deep space radiation. And that's why today's scientists are working hard to improve our ability to accurately forecast dangerous space weather.
The space we travel through. Presented by Science at NASA. When seafaring nations began to explore new regions of the world, one of their biggest concerns in making the journey safely was how to cope with weather. They could harness the wind for power. They could rely on the sun and the stars for navigation. They could build sturdy ships. But if a storm rose suddenly, they were at nature's mercy. More than 5 centuries later, our nation is once again on the cusp of exploring new worlds. And once again, one of our concerns about traveling long distances is the weather, space weather. While space is a vacuum, it's not 100% empty. Particles, energy, and magnetic fields travel through the void. Much of these emanate from the sun's corona, as part of a constant outward flow known as the solar wind, which stretches well beyond the orbit of Neptune. There are also high-energy particles or cosmic rays in the mix, which travel vast distances from dying stars or supernovae. Earth's magnetic field and relatively thick atmosphere act as a shield against the most harmful forms of this radiation, but in space, there is no such deterrent. If we want to travel through this space, We need ways to protect our astronauts. These particles can affect our technology, tripping onboard electronics. Dr. Yari Calatavega, space weather scientist at NASA's Goddard Space Flight Center, notes, "We are working hard to forecast when these particles will be at their peak, such as during solar flares or coronal mass ejections." Acute exposure to these solar energetic particles is a serious concern for astronauts and instruments. Therefore, having a better understanding of when to expect solar activity is important for safely sending our astronauts and spacecraft through space. Ironically, such space weather activity can actually protect against another threat to astronauts. The sun's activity can block dangerous cosmic rays coming from other stars, which are constantly present, illustrating the complexity of the system NASA tries to understand and mitigate for our space travelers. Over time, sea captains learned when to sail their ships and when to stay in harbor, based on their accumulated knowledge of the weather. It's more risky to be on the water in the Caribbean during hurricane season, and you'd want to consider avoiding the northeast coast of America during the height of winter. Dr. Calatavega says, "It's very similar to what we're doing today. We're constantly developing and testing new models to predict space weather, and we're constantly seeking new data to refine those models." A host of heliophysics missions observe space from a variety of vantage points, not unlike terrestrial weather sensors, which work in tandem to paint a bigger picture of our space environment. In August 2018, NASA launched the Parker Solar Probe to help us better understand the sun's activity, especially what drives the solar wind and how energetic particles get accelerated. This data could be used to improve models of space weather forecasting, ultimately helping us find new and better ways to shield our spacecraft and protect our astronauts. Whether it was the oceans ancient ships traveled through, or the space we will one day travel through, we know this: keeping a watchful eye on the environment around us is key to ensuring safe passage. For more information about what matters in space, visit science.nasa.gov.
If you'd like another look at any of these stories we showed you today, go over to YouTube and Facebook at those addresses right there. You'll find them all and plenty of other great features about a whole variety of NASA topics. And if you're looking for good conversation about human spaceflight, check out Houston, We Have a Podcast, our weekly show about all aspects of human spaceflight and NASA's missions of exploration. Today, Gary Jordan joins colleagues from across NASA to discuss the interesting ways that NASA spreads the details to the world on the agency's exciting missions and projects. Go to nasa.gov/podcasts for this week's episode. You'll find all the previous episodes there too, as well as the full library of all the NASA podcasts, which are also on Apple Podcasts, Google Podcasts, and SoundCloud. And you can get the latest from all over NASA delivered to you every week. Go to nasa.gov/subscribe to sign up for the NASA newsletter. You will thank me.